Hello everyone, and today we will be solving this problem. This problem is a parametric problem. And parametric problems, okay, they are new kind of graph. The graph we know is a simple x, y. Okay, I mean, it can look like this, anything, okay? But this has three variables. And we can make, from this two equation, we can make it into one equation that has two variables. So far, this has three. So we will eliminate the variables that have t in them as well as like sine and cosine, okay? Problems like this, you need to know that sine squared t plus cosine squared t is going to 1. Is equal to 1. So a way we can have sine squared t from this equation is we minus 2 on each side and then square both sides, okay? That way we get sine squared t as x minus 2 squared. And a way of getting cosine squared, okay, is when I subtract 1 on each side, divide 3 on each side, and then square on each side. Okay, right here it says that. So this plus this is equal to 1. So which means this plus this is equal to 1, obviously. Okay. You guys know how to graph problems like this, okay? This is just a simple circle that is the center of an origin and the radius of 1 because this is equal to 1. But, okay, minus 2 and minus 1, okay? That's just the displacement of where the origin is going to be, okay? If these two numbers aren't here, the center of the circle would be here, the origin of the graph. But there's a minus 2, okay? That means I'm going to have to have x is equal to 2 to make this a 0, okay? So right here, then a y go up once, y is equal to 1, so this can be 0 also. So this is the center of whatever the graph is going to be. And then, okay, another thing that I should show you guys, that is x over 3 squared plus y squared when it is equal to 1. When y is 0, x has to be 3. 1, 2, 3, and then also minus 3. So, because you get minus 1 and squared, that's just going to be 1 anyway. And then when x is 0, y has to be 1 and minus 1, making a graph like this, okay? It's like a potato. You know, because there's a 3, there's a 3. Yeah. But what if we have like this? There's a divide 3 on the y side is equal to 1. No difference. There is, which only from a circle, you will just stretch it vertically, okay? Like a pickle, for example. So when y is 0, x is 1 and minus 1, and when x is 0, y is 1, 2, 3 on the top and minus 1, 2, 3 on the bottom. All right. Yeah, very good. With all the information that I gave you guys, we know that there is a 3, okay? So through the vertical, okay? So this is the origin, so we go 1, 2, 3. This is the end point, okay? And then 1, 2, 3. And then a 1 to the right, 1 to the left, because there is an invisible 1 here. Okay, let's graph this. It will look like this. I didn't measure it well. Okay, it looks like this, something like this. And now, we're not done yet. We drew the graph of this, but we have an interval. You know, when t is bigger than pi over 2 or equal to, but smaller than or equal to 2 times pi. Okay? How do we do this? Yeah, I don't question that. I know how to do it. Well, okay. This is a starting point, okay? When pi over 2, when t is pi over 2, that's when it starts, okay? Like a initial point, you guys can say that it is. Okay, so when t is pi over 2, okay? Yeah, so t is pi over 2. Put it in here and here. Let's first do it in here. Sine pi over 2 is equal to 1 plus 2 is equal to 3. So x is 3. And then y is equal to, put pi over 2 here. Cosine pi over 2 is equal to 0 times 3 is 0 plus 1 is 1. All right, now we have a point. Yeah, 3, 1. Okay, so starting when t first starts, which is at pi over 2, we have 3, 1. So 1, 2, 3, 1. Okay, So the whole thing starts from here. Okay. Now let's put in pi, because that's in the interval of this. Okay. So okay, we have a room here. So when t is pi, put it in there. Sine pi is 0 plus 2 is 2. So x is 2. Okay, and when pi goes into there, that's minus 1. Okay. So yeah. Minus 1 times 3 is equal to minus 3, plus 1 is equal to minus 2. Is that right? Yes. Okay, so 2 comma minus 2. Okay, so 1, 2, 1, 2. Okay. We know that the graph moves in this way. Okay, little arrow representing it. Okay, starting from here, it goes to here, and then I can guess that it can go around here, but we don't know that yet. Okay, now let's try 3 times pi over 2, because that is still in this interval, okay? So when t is equal to 3 times pi over 2, what is x, okay? Let's put it in there. Sine 3 pi over 2 is equal to minus 1, plus 2 is equal to 1. Wait a minute. Yes. Now put that in there. Okay, I'm not going to explain to you guys anymore that any cosine of any pi times whatever the constant in front of the pi, when there's over 2, okay, well, no. Okay, cosine 3 pi over 2 is 0, all right, times 3 is 0, plus 1 is 1. So 1 comma 1. We get here, okay, we get displacement. So the graph goes like in this way, clockwise. Now let's have the t be equal to 2 pi. Okay, when t is equal to 2 pi, put 2 pi here. Sine 2 pi is equal to 0, plus 2 is 2. Okay, and now our y value. Put 2 pi over there, that is 1, 2, that is 1 times 3, which is 3, plus 1 is 4. Wow, very cool. Okay, so 2 comma 4. 1, 2, 1, 2, 3, 4. Okay, so it looks like the graph is like this, and then this portion is cut out, okay? Okay, with the blue marker, I will show you guys the answer. So the graph goes in this way, and the blue highlighted is the answer. So this portion is just like, yeah, not there because of the interval. And it goes this way. That's important. I don't know why, but answers want it that way on most of the books. Yeah. Thank you guys so much for watching my video. I hope you guys learned something. See you guys in the next time. Bye.